Lecture name of this lecture is a sound. Standard is Earth. My name is written over here. It's me, and it's showing this image is showing what hint. This image is showing discussion of this lecture. Discussion of this lecture. This image is showing. Let's start with the next slide. What is a sound? What is a sound? From this given definition, it is a sound is a form of energy produced by vibration. Produced by vibration. When vibration will come, then sound will come. Sound vibration both will happen together, but after 1 second, 0.1 second, sound will come. Sound is a form of energy produced by vibrations. It travels in the form of waves like this through a medium, here without medium vibration will not happen, without medium sound will not come. So to have a medium should be there to travel sound. It travels in the form of waves. Sound, you will see what it will be traveling in shape of waves like this. Shape looks like this. Wave looks like this. So always remember, direction traveling of a sound is not in a straight line. It is a curved. It is a curved. What? It is a curved direction of a sound. Yes, to propagate, to vibrate, there should be medium. Medium can be air, water, or solids. From this, you can understand, from this air, water, or solid, you are understanding that we should have three types of objects. Either we can have a solid shape, or liquid shape, or a gas material. Okay. So one of them you can have, and then we can vibrate. Then vibration can happen when there would be medium. With one alone object cannot vibrate. Alone object cannot vibrate, cannot produce vibration. Alone object. There should be two objects to produce vibration. Remember, there should be two objects to vibrate vibration. Always remember. And both can be what, solid, liquid, or gas material. It doesn't matter. But remember, in a vacuum, in a empty area, sound cannot travel. Sound cannot travel. To travel sound, there should be what? To travel sound, there should be something. Something can be air, something can be water, something can be liquid material, something can be solid material. Solid can be rigid, it can be flexible. It cannot travel through a vacuum. Vacuum, which means empty area. In a vacuum area, sound will not travel. Sound will not travel at all. Now, from this, you can also understand one thing more, is that a speed of traveling sound, a speed of traveling of a sound would be different. In the case of air, a speed of sound will be less, will be more less, you can say. With liquid material, in a liquid material, speed of a sound will be normal. Now, in through the solid material, a speed of this sound would be more. This is a difference between them, between these materials, in order to travel a speed, in order to travel sound. Clear? So you understood that a speed of a sound in these mediums would be different. In here, sound of a speed of a sound would be less. In liquid, speed of sound would be normal, and in solid, speed of a sound would be more. This is what will happen. It happens naturally. This is not uh, this is not random things. Okay, it is happening. It will be happening. One example I can give you: lightning, thunder. You hear sound of lightning in the sky. You will realize that sound came after few seconds. After after coming what, lightning. Lightning will come before, but sound will come later, after just a few seconds. Why it happens? Reason is that sound travels in sound travels sound which comes from a sky, it travels in the air. In the sky there is a air. There is a air is present in the sky, and work of air is to block the upcoming sound. Air will be blocking the sound, and that's why uh, the sound reaches to us late. Reaches to us late. This is reason. This is a reason. Okay. Now I am moving forward. From this slide, you understood that sound can be produced by vibrating, by vibrating, and it will travel in the air. It will travel in the air. To vibrate vibration, there should be medium. Medium can be liquid, solid, gas. It will not travel. It cannot travel in the vacuum area, in the empty area. That's it. We understood in this slide. Now here you have two figures. You have one figure. Just visualize the meaning of this sound. Here sound is coming from this source. Isn't it? It is happening. Sound is coming from this source, and this sound is reaching to this ear, and this is how sound reaches to our ear, and we are able to hear the sound. This is how. And here you can see wave, direction of a sound. It is curved. It is a curve, isn't it? It is not in a straight direction. So remember, light travels in a straight direction, but sound will not travel in a straight direction. It will sound will be, direction of a sound will be wave, and uh, direction of light will be straight. Clear? So here it sound vibrates here, and it comes out, and it starts traveling. Some sound reaches to our ears, and some sound go into another direction, isn't it? So first of all, vibration will happen, then it will come out, then it will reach to our eye, our ear, and some sound will go into another direction. This is what happens, and this is how we are able to we are able to hear sound. Now in the next slide, let's see what is there, how sound is produced. We saw that yes, sound vibration will happen, then sound will come. Vibration will happen, then sound will come. Vibration will happen when there are mediums. When there are mediums, then vibration will happen. And mediums can be what? Again and again I am saying, you know what are those mediums. So let's see what is that process from which sound can be produced. So sound is produced when an object vibrates. So let you can take two objects. You can take two objects and just use those objects. You can apply like this force. Then what will happen? Vibration will happen. Vibration. Like this. Vibration will happen like this. This is it is invisible. We will not be able to see it directly. It is invisible. It is invisible. Sound is produced when an object vibrates. First of all, object will vibrate. Then at the same time, sound will come. First step is to vibrate, and second is to come out a sound. Okay? So sound will come when vibration will happen. Remember that. Example: guitar, string, tuning, fork. These are examples in which we can see vibration, happening vibration. Here we are using our hand, and second object is a guitar, and we use our hand. So like this we use. So here vibration you can observe in this object. By using this object, by using guitar, you can see vibration, and at the same time sound will come. Vibrations make surrounding particles vibrate and carry the sound forward. Yes, uh, as you know, surrounding us, air is present surrounding us. When vibration will happen, of course, the vibration will disturb to air to air. Air is in rest. I think it can be in motion. It can be in motion. It can be in a rest. If air is in a rest, is in motion, then air will start accelerating when vibration will happen. Then, isn't it? It happen or not? Of course, it will happen. So when vibration will happen, then air will start accelerating. If air is in motion, then now what if air is in a rest and vibration is happening? Vibration starts vibrating. Object starts vibrating. Then what will happen? Air which is in a rest will come into motion when vibration will happen. When vibration will be produced by using two objects. Are you understanding? So here vibration is disturbing the state of air. The state of air. Who is disturbing? Vibration. And this is the way sound reaches to us. Then then air next to the ear will disturb to next ear, and it will keep happening, isn't it? It will keep happening. And in this air you will get a wave of sound in curve shape. Okay, here you can see this is ear, and let's assume this is object. Here there are particles, and sound is going in this direction. Particles are disturbed because of a vibration happening. Then particles are disturbed. In details, let's understand this. Let's visualize this. Here, object is vibrating. Now, this vibration is disturbing. This state of air. This air is in motion. Was in motion. Now it started. It starts accelerated. Now motion of this air would be speed of this uh, moving air would be more because of object is vibrating, object was vibrating, and this is how a sound will reach to us, and this is how sound will travel and will reach to our ear. And here this is vibration. Okay, clear? This is clear. How will sound be produced? How will sound be produced? Object will be vibrating, object will be vibrated, then it will disturb the state of air, then in the air, through the air the vibration will travel, then it will reach to our eyes. This is how sound is produced. This is a process of a coming sound, of a going sound. Clear? I am moving forward. We have a propagation of a sound. It is something else, but now we will visualize more. We will visualize more. Propagation of a sound, it needs a medium, as we saw that to vibrate as well as for propagation of a sound, of course we should have mediums. We should have mediums, remember, solid, liquid or gas. So for propagation of a sound we should also have mediums. Okay, travels fastest in solid, we have seen, but again I am not ignoring it. It will be, it, if I repeat this then it will be more clear to you. Clear? So here sound travels fastest in solids, slower in liquid, and slowest in gases. You can see a speedness, fastness of the sound in different medium. In the solid, a speed of the sound is more. In this liquid, a speed of the sound is normal. In the gas, a speed of the sound is less. And this is a nature. This is the nature of a sound, as we saw nature of a light. No propagation in vacuum. Same as we were saying that vibration will not happen in vacuum. Same here, propagation will not happen in vacuum. A space is silent. Okay, but reality is what we see, that there is air which is a present in the sky surrounding us. Air is a present. If you take a beaker, if you take a bottle, if you take any object which can have what, which can have a space, which cannot have air, then just for experiment you can see what will happen. Is there happening propagation of a sound? Is the object vibrating in vacuum? You will see no, it is not happening. Clear? So in this, here you can see particles here are more, and here particles are less. So particles, area where particles are more will be considered something else, but area where particles are less will be considered something else. I don't know, right? So here I can tell you, I think air pressure, compression. Let me zoom in this. Let me zoom in this so that we can understand. Here we have this figure. What is happening here? what is happening here? This is sound source, this is sound source, and here these are particles. Here it is a source which vibrates. Now this vibration is disturbing this sound, this air. In this wave of a sound will travel. Here you can see area, this area. Here particles are more, here particles are less, here particles are more, particles are less. So let's name it. Okay, let's name it. This area where particles are more will be considered as a compression. Wherever you see compression word, you just understand that yes, this is area where particles are more, and area where particles are less will be rarefaction. Clear? Vibrating diaphragm, it is a louder speaker. So you saw that area where particles are more will be considered as a compression, and area where, in the other case, area where particles are less will be considered as a rarefaction. Clear? Now, rather than taking always this, we can draw a wave of a sound like this. This is a standard. It will be standard. You will get a clarity from this diagram. It is both are same, but it is a visualization and it is a diagram in the graph. Okay, it is a diagram of this. It is a diagram in the graph of this figure. So here let's see what is this, what is this space, what is the name of this space, what is the name of this line, what is the name of this line, what thing can be considered what. Okay, so here this is a height, as you can see, this is a height, we will consider it as a height. Now all these are air particles. Okay, all these are air particles. Here you can see this wall is a compression. You will consider it as a compression, remember. And this space will be considered as what? This space will be considered as what? Rarefaction. Here you will understand that it is a space, it is a place where particles are less, and this is a place where particles are more. Remember. Okay, remember. Now let's say wave crust and wave tuff. Here this surface, over here surface, this surface will be wave crust. Okay, remember. And here this downward, this surface of this wave will be wave tuff, remember. This wave crust and this wave tuff. From this figure you can understand about frequency, you can understand about wavelength. Remember, from between distance between two wave crust will be wavelength. Here this one wave crust and this one wave crust, between this distance is what? Between this distance is wavelength. Remember always. Clear? Now what about wave tuff? Same here, downward you can see this wave tuff. So distance between two wave tufts, this one and this one. So distance between them is what? Distance between them is wavelength. Okay, so here we will take what? Distance between two wave crust, and here we will take distance between two wave tuff, and this will be one wavelength, and this will be one wavelength. One, then again two. Okay, 1 2 3 wavelengths, like this we consider wavelength. Okay, so this is height, amplitude, and this is a horizontal line, this is vertical line. It is how this is how we represent a figure in the graph of propagation of a sound. Clear? About amplitude, about frequency we will understand later in next slide. But for now, here you can see longitudinal rarefaction, compression. Now I am moving forward. Here this line will be considered as a time. Here within how much time, how much wavelengths passed will be frequency. One to number of wavelengths will be frequency, number of wavelength will be frequency of a wavelength. Clear? Within a how much time, within a how much time, how much wavelengths passed will be frequency. So how to calculate what frequency? uh, Here is, there is a formula to calculate a frequency. To calculate frequency, okay. So here characteristics of a sound. Here I think you will have more knowledge about propagation of a sound. So characteristics of a sound, I was saying that we will understand about amplitude, frequency. So this is where you will understand. So characteristics of a sound, first is amplitude. Amplitude will determine loudness. Loudness is more, loudness is hard, less. So it will depend on amplitude. Amplitude, it will depend on amplitude. Where is amplitude? Where is the amplitude? So here, as you can see, propagation of a sound, this is compression, this is a rarefaction, and here refraction. So this figure is for you. So remember, amplitude will determine, amplitude is just height. Amplitude is just height. If height would be more, then loudness would be more. So amplitude decides loudness. Frequency will decide pitch. Pitch, frequency. If a frequency is more, pitch will be more. If a frequency is less, then pitch will be less. Time period. Time period, time taken for a one vibration. One length or one vibration. Okay. So time period. How much time was taken just for one wavelength will be time period. Okay. So wavelength, distance between two compression of or a rarefaction or rarefaction. Clear? Our focus will be more on frequency and amplitude in the next slide. Here about it, I would like to explain here. Here we can see this is object and vibrating is happening from this object, and it is what? It is particles. It is particles. Now here, this is area where particles are more. You can easily see here density is more. Density of the particles are more. Particles here are more. So this area will be considered, we will consider it as a compression. Area where particles are less will be considered as a rarefaction. Clear? This object, this is fraction, this is rarefaction, this is a compression, this is a rarefaction, this is compression, and vibration is going in this direction. Vibration is going in this direction. So this slide is clear. This slide is clear. Hold on. So here we were understanding. So this slide is done. Okay. Let's move towards this slide. Audio and inaudible sounds. Audible range, audible range, audible range for women. Here you will understand what is the audible range for human. If you are with me, then you can drink water so that you can have energy. Okay. Are you ready? Audible and on inaudible sound. It is also very interesting. It will not be difficult to understand it. I promise you, it is very easy to understand. Look, we hear a lot of sound. So what is a how to measure sound? Okay, sound is measured in hertz. Hertz. Okay, if sound is more then our ear can damage. But question is how much sound? With how much sound our ear can damage? This is the main question in this slide. And if a sound is less, how much sound should be less, then we will not be here to sound. This is the question in this slide, and you will get answer of this question. So look, for human, sound from audible range from 20 hertz. 20 hertz. We can hear sound of anything if sound number of a sound, not number, sound is above the 20 hertz and below the 20,000 hertz, then human can hear that sound. If that sound is between 20 hertz and 20,000 hertz, then human can hear. Remember? Now your question, I am taking your question. You were saying if a, okay, human can hear sound between 20 hertz and 20,000 hertz. What if sound is more than 20,000 hertz? Then what will happen with human? Here, if sound is more than 20,000 hertz, then your ear can damage. How much it sounds? 20,000, more than 20,000 hertz. Then our ear can damage. Okay, this is your and this is the answer of your question, of your first question. Now, what about the second question? You were saying if a sound is less, then what will happen with human? Remember, if a sound is less than 20 hertz, then human cannot hear at all. Human cannot hear at all. If sound is less than 20 hertz, then 20 hertz, then remember. What are you understanding? You are understanding audible range for human. If hertz is more than 20,000, then ear of human can damage. If sound is less than 20 hertz, then human cannot hear. So, wo hear if a sound is less than 20 hertz. So, elephant, elephant, elephant can hear. If a sound is less than 20 hertz, then elephant can only hear. We cannot hear this much sound. Clear? Now, if sound is more than 20,000 hertz, then who can hear? So here, these bats can hear. These bats can hear. If a sound is more than 20,000 hertz, then this bats can hear. Here you can visualize. Here you can visualize. This is a line, and in this line is written infrasound, audible range, and ultrasound. Ultrasound is what is a sound number which is more than 20,000 hertz, and infrasound, which is a number is less than 20 hertz. Clear? Here, this audible range, which is between 20 hertz and 20,000 hertz. 20,000 hertz is for human, and this infrasound is for this elephant, and this ultrasound is for this bat. So ultrasound, what is ultrasound? If someone wants to ask this question, then what will be your answer? What will be your answer? So your answer should be what? Ultrasound is a number of a sound which is more than 20,000 hertz, and infrasound is a number of a sound which is less than 20 hertz, and audible range for human is what? Between 20 hertz and 20,000 hertz. This should be your answer. This should be your answer. And here you can see, if for infrasound wave would look like this. For audible range, it would look like this, and for ultrasound, it would like this. You can observe what is happening with this wave. Now, this slide is clear. And what did you understand from this slide? You know. I also know, but I am not going to explain what did you understand from this slide. Okay, I can say you understood audible range for human and inaudible sound for human. Clear? Now moving to the next slide. Sound produced by humans. How do we produce sound? This is the question. We can produce a vibration by using two objects, except human. But what if? Question is, how does a human produce a sound? Where does vibration happen inside the human? This is main question in this slide. This is main question in this slide. In each slide, there would be questions. In each slide. Okay. In this slide, question is, where does vibration happen inside human? How does human produce a sound? I am speaking. This is sound. I am speaking. This is sound. So question is, how am I able to produce a sound? Alone I cannot produce. There would be what? Inside me there would be what? Vibration objects. A object which will be vibrating. Which is vibrating. Then I am speaking. Then I am able to come out a sound. So what is the name of that part which is vibrating inside me? Then sound is coming. What is the name of that part inside me? So name of that part is this. Is what? Name is what? Vocal cords. Vocal cord is a part of the human where vibration happens. It is a part which vibrates to produce a sound. It is available here. It is present over here, inside womb. Here, if you put your finger over here and you start speaking, then you can feel vibration. So, did you get your answer of your question? Yes. So here is a vocal cord which is a part of a human body, and this is where vibration happens. This is where it vibration, this object vibrates, this thing vibrates, then we are able to come out a sound. Clear? So human sound is produced by the vocal cords. It is the name of a part of the human body. Vocal cords vibrate when air passes through. Tension and length of cords affect pitch and loudness. You will be realizing to see someone what someone 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 sometimes would be speaking, and sound of nature of a sound, nature of a sound of that person would be change, and it happens when we take a tension mode. When we take a tension mode, then it happens. Clear? Then it happens. Tension and length of a chords affect pitch and loudness. Clear? Reflection of a sound. Reflection of a sound. As we saw reflection of a light, same here you will realize. uh, you will realize sound reflects of a hard surface echo. Always remember there should be a solid, not liquid, not a flexible liquid, not a flexible sound, solid. Okay, sound will reflect when sound when sound will hit the object hardly, and it will happen when solid will be raised, then reflection will happen. Reflection of a sound will happen. Okay, sound comes out from the source, from the object by vibrating, then it goes into another direction. Some sound will hit on the object, and if object is a rigid, object is a solid, rigid, then it will, then sound will reflect into another direction after hitting the surface of the solid. This is what will happen with a rigid solid shape, rigid solid object. Clear? Echo heard when sound reflects back after 0.1 second or more. Used in sonar, stethoscope, or auditorium design. What is echo? Echo is just a reflected one reflected sound. One reflected sound is echo. Your voice, if you produce a sound by vocal cord, then you will be able to hear your same sound after 0.1 second. This is what echo. This is echo. Echo is just a reflected, one reflected sound. Echo is just one reflected sound. Clear? Okay, so as you can see, this is a alarm clock, and it will vibrate after hours. It will start vibrating, then some vibration of this will go this direction, this direction, this direction, this direction. So some sound will hit on this surface, it will turn into another direction because of this is a rigid material, that's why. And we are here, so like this it will reach to your ear, remember, if this is flexible, then the sound will be observed. Sound, it will observe sound, it will observe sound. Okay, rather than reflecting, some sound will be observed by flexible sound, remember. Okay, here you can see there are two persons, there are two women. This is wall, and both are vibrating, sound is going, then it will reflect into another. Then after 0.1 second, both will hear sound. Just after 0.1 second. I'm not saying 1 second, 0.1 second. You can think what is a 0. What is the number of a 0.1 second? Clear? I think this is a done. Echo is what? Echo is just one reflected. I'm not saying 3, 4, 500 reflected. No, only one reflected is a echo. Echo is a sound which we hear after 0.1 second. After 0.1 second, always remember. And here we saw reflection of the sound. Object will vibrate, then it will hit. This vibration will hit on the surface of the object, then it will get a reflect into another direction, then that sound will reach to our eyes. Even directly sound can come into our ear, directly can come. Okay, if there is an object which is blocking the which is resistance for the sound, then then sound can reflect just by hitting the surface of that object which is a resistance. So this is done, I think. Next is the musical and noise. Next is musical and noise. Whatever sounds you are hearing, if that sound is not interesting for you, then that sound will be noise. Noise, okay. Whatever you are hearing, so that sound provides pleasure to you, then that sound will be musical. That's it. Any sound, if you don't want a sound, that sound will be noise. Any sound which is pleasure for you will be musical. Musical sound, pleasant and regular vibration that comes from instrument. Noise, unpleasant irregular vibration which comes from traffic. We don't It is unwanted sound which we don't want to hear. Traffic, I'm talking about the traffic. Let's move towards this slide. Next is noise pollution. Next is noise pollution. It is a noise pollution. This is harmful, isn't it? This is harmful. It can affect our body, isn't it? It is affecting our body. Even we can see in our city, there are a lot of voice which some some sound comes some sound comes from vehicles, some sound comes from factory, some sound comes from people. Sound of a people is normal, but sound of a vehicle, sound of a factory are harmful for human. It is a pollution. I'm not saying population, it is a pollution. So causes horns, loud speakers, machinery, traffic. These are sources that produce noise, but we cannot. But person cannot stop doing work in home by using loudspeaker. In home, person cannot stop using machinery. Person cannot stop going outside, of course. So that's why here there are no solutions of this problem. But in future there can be solution of this problem. But right now solution is a what is a just planting tree. Just planting tree. Tree can be anything. It can be mango, it can be apple, it can anything. There are a lot of fruits. Okay, just by planting trees, noise pollution can be reduced. Effects. What will be effect of noise pollution? It can damage our ears. It can affect on our body. We can be able to go hospitals because of noise pollution. Okay, anytime we can come into category of a disease, but this we don't want. Okay, control planting. How to reduce noise pollution? Just by planting trees. Just proofing is a control of noise pollution. Limiting volume. If you increase volume which is unwanted, will damage, will affect on human. Now next, we have a question answers of this lecture. First question is, what produces sound? Vibration. Object vibrates, then sound is produced. What is the audible range for of a human hearing? Just between a number between 20 hertz and 20,000 hertz is a audible range of a human hearing. What are the characteristics of a sound? Characteristic: amplitude decides loudness, and frequency decides pitch. Pitch. If a number of frequencies is more, then pitch would be more. If a number of frequencies is less, pitch will be less. Uh, Amplitude is low, then loudness would be low. If amplitude, as I said you, amplitude is just a height. If a height is more, then loudness would be more. And time period. Time period is just time taken by vibration. If one vibration is taking how much frequency, within a how much time passed. This is what time taken. One vibration within a how much time passed. What is echo? What is echo? Echo is just one reflected sound. One reflected sound. When is it heard? After 0.1 second. After 0.1 second. What is the noise pollution and how can it be controlled? Noise pollution is just a noise which human don't want to, human does not want to hear. Okay, it comes from traffic, it comes from factory, it comes from a lot of places which are noise pollution can affect to human indirectly. Human will be able to go hospital because of noise pollution. And this noise pollution can be reduced just by planting tree. It will be useful if we plant a tree. Then what else? By awareness, noise pollution can be reduced, but it will be possible, it will be impossible just by, it will be possible to reduce noise pollution just by awareness. Possible is more when we will plant trees more, then this here possible will be more. Next, the end. That's all.